Wait. It didn't work for Twitter, so let me take it off. Hello, everybody. Hello.
No, we're testing the volume. Oh yeah. Because I wanted to.
Let me get the volume up a bit. Está muy bajo. Yeah. Hello. It's not showing it quite yet. Okay, there we go. Hello. 1, 2, 3. Better now. A little bit. Okay, guys, keep it down, guys.
You guys all hear me? Are you guys able to hear me?
Yes.
Okay, awesome. We are about to get
Miami, can you hear us?
Okay,
There we go.
that was me. So we're going to do that again, and I'm going to rotate all of you guys. Miami, can we get a hello? Awesome. My name is Larissa. I am supportive of GPTuesdays, and I just wanted to thank all of you guys here for coming out for the collaboration between Miami-Dade's AI Center, GPTuesdays, and GenAI Collective. So without further ado, I'm going to introduce Jose to come up from Miami-Dade, and then we'll go ahead and introduce everybody else.
Hello, everybody. Welcome to the AI Center here at Miami-Dade College. I'm not going to plug a lot of things, just two things that I like to say always about MDC. One of the largest colleges in the US, 125,000 to 140,000 students. And 90% of our students graduate without student debt. Nice. So we're really going against the grain, getting So that's all from me. Very welcome to keep having you here every week. It's a great program, GPT Tuesdays, organized by our friend Grant. So over to Grant.
Yes.
Thank you, everyone, so much. This is a very special day. We are GPT Tuesdays, the very largest and longest running AI weekly meetup here in Miami. In collaboration, this event is with the GenAI Collective. We are very, very excited for our collective and collaborative event. I want to talk to you a little bit about what is GPT Tuesdays. GPT Tuesdays is a leading AI, we help to bring together AI engineers, developers, researchers, students and enthusiasts looking to learn more about AI so that we can all grow and learn together. And that's what we're all about. We want to continuously educate people in Miami and as well as everyone around the world on artificial intelligence and everything in between. So without further ado, let's bring up Aman, a really good friend of mine from the GenAI Collective.
Hello. Is it working? Okay, it is working. Put a round of applause for my guy, Grant, for hosting GPT Tuesdays for free. He doesn't charge us anything. He just does this for love of community, no sponsors, right? Like when we were thinking about doing a collaboration with GPT Tuesdays and GenAI Collective, he didn't even flinch once and said like, yeah, let's do this. So that's what we need more in Miami. And so I'm going to tell you a little bit about the GenAI Collective. So GenAI Collective was actually started a year and a half ago in SF. It's a 20,000 plus community of AI enthusiasts, including founders, researchers, and builders. And we just started our chapter a month ago in Miami. We had a Miami kickoff event, and I can see a lot of familiar faces. A huge round of applause for the same comers and trying to make the whole community going on. So without further ado, I want to actually share some community values that we hold for GenAI Collective. So when I came to US for the first time, I needed a sense of belongingness. And GenAI Collective gave me that sense of belongingness where I can learn, grow, nerd about the GenAI stuff because your family doesn't want to talk about all this nerdy stuff, right? So you need those friends. So it gives me that 1+1 connection feeling. So every person here is a new connection made. So if you don't learn anything from the speakers, awesome speakers, by the way, just remember you want to have that one extra connection that you can walk away with. And maybe that could be a future co-founder, a future co-worker, or maybe just a future friend, right? We believe in positive sum game. We don't take any sponsors so far, and it's a completely non-profit, and we believe in positive sum game. Anything that anybody is bringing here, adds some value to somebody else. So that's what we believe in. And we don't believe in resume. We believe in authenticity. What people know, what they share, not where they come from or where they are in the current stand of life. And finally, we appreciate all the participation and all the engagement. This wouldn't have been possible without you guys and, of course, the amazing community host. And again, enjoy the event, be curious, and let's see where it goes. So this is what the agenda will look like. We already crossed the first 40 minutes. We're going to have 3 awesome speakers, Aleksey, Alex, and Kai. We'll be talking about building GenAI products, whether it's agents, doing prompt engineering. So even if you are new to AI or an expert, I think there is something that everyone can learn. So without further ado, I'm going to call upon the stage our first speaker, Aleksey. Put a round of applause for Aleksey. Yeah!
Hi. Hello, everyone. Is mic working? Can you hear me all? Yes. Okay. Okay, thank you.
We're going to go ahead and give you the StreamYard. You just need a quick activate.
Okay, let me think. So, can you put,
Yeah.
okay, we can see the screen. And this is StreamYard.
Here's share screen. Entire screen. All right.
Hello, hello. Let's first make a selfie before we start. Say hello.
Hello.
GPT Tuesday.
GPT Tuesday.
All right. So my name is Aleksey. Let me quickly introduce myself. I'm a deep learning engineer with 8+ years of experience in different fields like NLP, computer vision, personalization, and predictive analytics. I have a software engineering background as well as machine learning and deep learning experience. And today's workshop or lecture will be really educational. We will cover historical evolution of NLP field. For the ones who are not familiar with NLP, NLP is a natural language processing. It's a name of machine learning domain where all generative models are coming from. And today we will explore how the domain was developed. We will discuss TF-IDF. It's a first statistical model for informational retrieval. This algorithm was used in the first search engines. Also, we will look into recurrent neural network architectures, LSTM neural networks. Also, we will understand how language modeling works and why it's so powerful technique. And we will look into very detailed into transformer architecture. And we will finish our presentation with pre-trained LLMs. So what's NLP use cases? NLP is a set of algorithms that are used in different tasks. For example, in document scanning, in Google Translate. Also, all chatbots are using NLP algorithms like ChatGPT and Anthropic Claude. All of them are using these algorithms. And speech recognition as well is using NLP. What is a good part about NLP is that these powerful algorithms were designed to solve NLP tasks, right? But then, after they developed, they were scaled to other tasks. For example, into protein folding or any sequence modeling. For example, where we have sequence nature of the data. In our DNA sequence, we have amino acid sequence, or we have a human interaction history in the website. We have a bank transaction when we pay anywhere, we have transaction history. And all of that is sequence data, and we can use same algorithms to solve for that tasks. I think first very theoretical methods were published by Noam Chomsky. It's called Chomsky grammars. He introduced 4 types of grammars. It's rule-based models where you can specifically, explicitly define your generative model. For example, you may be familiar with regular expressions. Regular expressions are a good example of Chomsky grammars. Also, all compilers that we use to run our programs, they are also using Chomsky grammars. Chomsky grammars allow you to check if the generated text is accepted by rules, and the rules are defined in your grammars. And it can be used even now. For example, if you build a generative model to generate programming code, you can add Chomsky grammar post-processing, which will validate your code, if it's compilable or not, if it's synthetically correct or not. And you can apply it on top of Beam search, and it's still useful. And these methods already exist for 7 decades. After that, in 1972, one of the first statistical models was introduced for NLP. It's called TF-IDF. It's also a very powerful algorithm, and it can still be used as a baseline for many tasks. And in 1980s and 90s, neural networks were proposed for sequential data, RNNs and LSTMs. We will explore them today. And a decade ago, 2 methods were proposed for sequence modeling or for language modeling, sequence to sequence and word to vec. These are very powerful methods based on self-supervised learning that can accelerate your model performance using learning the underlying structure of the entire data that we have in the internet. For example, we can use the entire Wikipedia to pre-train our model using these 2 methods. And starting from 2015, attention mechanism-based models were proposed, and all state-of-the-art models, they're all using attention mechanism. And this is the key tool of the power of the current models. And in 2017, we had a very famous paper published, Attention is All You Need, where transformer architecture was introduced. It's a very, very powerful and scalable architecture that was used later in state-of-the-art pre-trained models, including BERT, GPT, and others. And starting from 2018, there are not much innovations in NLP. all of the innovations were achieved by scaling the data and computation power and optimizing the existing algorithms, existing methods. Why it's good to know about the whole picture of the NLP, because you can still mix the methods. For example, you can use RNN and LSTM ideas in transformer architecture to introduce infinity attention. For example, current transformer has limitations of sequence length. You can use the ideas from RNNs to accelerate sequence length, to increase it. Or you can use Chomsky grammars to check the correctness of the generated result. Let's look how TF-IDF looks like. This is basically a simple formula which was used for information retrieval in the first search engines. Let's say you have search query and you have to find websites which are the most relevant to your search query. First, you need to calculate how many times you have your search query, how many times it occurs in each website. Let's say you have 20 times appearances of the search query in the document. The second term is called document frequency. You have to count how many documents also have this search term. And let's say if you have document where you have search term is very frequent, it has many occurrences, and you have no more documents in your data set with those search terms. It means that this document is very relevant to your search query. Another case, if you have many documents who also have this search term, it means that document frequency will be high. That's why we use inverse document frequency. If we have high document frequency, we want to reduce score. It means that this term is very popular across the entire data set. And by multiplying term frequency with algorithm of inverse document frequency, we get score, how relevant the document for search query. And we can build the matrix of the documents and the tokens pairs. And this matrix can be used for search. For example, let's say you have English vocabulary, you have 50,000 words, and you have your websites. And for each website, you calculate TF-IDF score, and you have a multi-dimensional vector. And now you can calculate document similarity, or you can find closest documents to your search query using distance metrics like Euclidean distance or cosine similarity. This method is still very powerful. Let's look into recurrent neural networks. Recurrent neural networks, it's a naturally designed model for sequential data. Let's say you have a sequence of tokens and you have RNN cell. This is neural network unit. And in this neural network unit, you have two inputs and two outputs. This is basically the same output. And you have just one fully connected layer in the neural network unit. And each input is next token. For example, in your sentence, each word will be new input. And second input is a recurrent. Basically, the output of the neural network cell will be input of itself. That's why it's called a recurrent. And at each step, you have hidden state for each timestamp. And these recurrent neural networks were first proposed for natural language processing. And it still can be used for many tasks. It's useful because it can process infinite sequence length. You can have very long sequence, and it doesn't have any limitations. Also, it's very natural for sequence data architecture. However, it has several disadvantages, like vanishing gradients. In the long sequences, the information is getting forgotten. And also, it's very computationally expensive. If you have a long sequence, it will be very computationally expensive. And it's also often that models are overfitting. LSTM models were proposed 15 years after. They introduced three more gates in the unit. First one is called forget gate. It's required to forget information from previous tokens that are not relevant for the task. Second one is called memory gate to memorize important information. The third one is called cell update or hidden state update. And the last one is called output gate. So it has 4 gates. It's more complicated architecture, but it's very powerful because it can memorize context for long sequences. RNN is keep forgetting information, but LSTM is more powerful for long sequences. And 10 years ago, first sequence models were proposed. What is sequence model? Let's say abstraction. Let's imagine an abstract task where you have one input and one output, and we can imagine it like a word classification task. We can classify word. Text generation, we can have one input and we have many outputs, many tokens. We just prompt one word and model will generate multiple words. We can have multiple inputs and one output. It could be text classification problem. For question answering, we have multiple inputs and multiple outputs. And for machine translation, we also have multiple inputs and multiple outputs, but the number of tokens are similar. And one of the first methods for language modeling is called word-to-vec. The main idea of word-to-vec is to represent the language in the multi-dimensional space. In this picture, you can see, for simplicity, 3 dimensions, X, Y, and Z, and each word is represented by 3 dimensions. It's just 3 numbers. And the goal for language model is to put the position or the point in this multidimensional space where you will have similar relationship like we have in the real world. For example, if we measure the distance between man and woman, the distance should be mathematically equal or similar to distance between king and queen. And same for the entire language. It will build the model of the real world in this multidimensional space. And how to do that? Simple neural network architecture is used. Let's say we have Wikipedia, our data set, and we define a window, let's say 5 words. Every 5 words, we will have a sliding window. And each word will be one hot encoding vector. And we will randomly mask each of the words from these 5. And the rest 4 will be used to predict mask token. And by going through the entire Wikipedia multiple times, like let's say we will run 10 epochs training across the entire Wikipedia, this model will get a representation for all words in the Wikipedia data corpus. And a similar approach called skipgram, where instead of context, we use just single input to predict context. And starting from 2015, attention mechanism was proposed. The main idea of attention mechanism is to teach the model to put attention on specific words that are really relevant for the task. The model will learn how to weight the tokens, how to weight the words, to get the best results. And it's using a function called softmax. It's very simple mathematical function, which is used for normalization, where you have input vector, and at the output you will get probabilities. And the sum of the probabilities will be equal to 1. And this simple formula is used in every attention mechanism, and it's very powerful to get state-of-the-art model performance. And now we can start looking at transformer architecture. The core component of transformer architecture called self-attention. Self-attention is a very efficient mechanism to learn underlying structure of the data. So give me a moment, please. Sorry for that. So first step will be to build queries, keys, and values. So let's say we have our vocabulary. For the vocabulary, we have embedding space, right? We already discussed what embedding space is. It's multidimensional representation for all tokens. And we have 3 weights matrices, queries, keys, and values. And the dimension, number of dimensions in this matrix, we can define. So it's not some magic number. We can define. We can try 16 or 32 or 128, depending on the data set size. And number of rows in this matrix should be equal to number of columns in this embeddings. And we will multiply this. We make matrix multiplication, and we get keys representation. And then we get queries and values representation. Second step, we have queries, keys, and values vectors. You can see them here. Red color vector is query, key is yellow, value is purple. First you have to do is matmul operation. This is element-wise multiplication between queries and keys. You multiply first position with first, second position with second, third position with third, and you run it for all pairs. You have, let's say you have 10 tokens in the input, and you run multiplication for all pairs of the tokens, and you get score, scalar value. After that, you make normalization, you mask some of the tokens, then you use softmax that we discovered before to weight those scores, and you get new weights. And then you multiply value vector with your score, and you get output. And this output will be matrix, squared matrix, called scale.product attention. And in transformer, they introduced multiple those heads. You can have like 8 transformer heads. And math is very simple here. Nothing really complicated. And this component is called multi-head attention that we discovered in previous slide. And in the paper, they introduced multiple those layers. And each multi-head attention is followed by normalization layer, feed-forward layer, and another normalization layer. So, and in transformers, they have encoder and decoder. Encoder is used for classification tasks. For example, a BERT model is an encoder. A decoder is used to generate text. For example, GPT models are based on this decoder part. And at the output, you can have some custom function. What are main advantages of transformer? First one is scaling and parallelization. You can use this model to run on many GPUs on the huge data set, and it's very efficient in terms of scaling. However, it has limitation. It has a squared it's very computationally expensive to run those pairwise matrix multiplication for all tokens. And it's still computationally expensive. That's why new models were introduced that use only queries and keys instead of queries, keys, and values, or some other optimizations. Also, is very efficient in terms of handling hidden relationship in the data. But it's computationally expensive, and it lacks of recurrence. Like in a recurrent neural network, it can be used for infinite sequence lengths. And self-supervised learning is a powerful technique that can be used on top of transformers. The idea is to train the model to learn the underlying structure of the data. For example, the model is trying to predict masked tokens, or the model is trying to predict if the second sentence B is following sentence A. These are two tasks. And you can design many tasks in the language, and the model will learn the representation and the world understanding on that language. And if you have this scalable model, and you can use it to pre-train on the huge corpus of the data, on the entire internet. And after you pre-train this model, you can use it to fine-tune on very specific tasks. And the main idea was in self-supervised learning that if you teach the model to predict very simple tasks, like predict next token, and you use the huge computation power, huge number of GPUs and a huge data set, it will be very generalized for many tasks. This is basically it. If you have any questions, let me know. Okay.
Any questions? Please. Yeah, sure. We have another microphone.
Thank you so much for this presentation. For the details, I really appreciate it. I have a question. I really listened to the podcast, and they were talking about machine learning, and that means like smaller models. There was no machine learning, but in bigger models, we started seeing machine learning, and people also mentioned self-supervised training. Are these the same things? And can you explain why machine learning is so important?
Thank you for the question. Self-supervised learning, as I mentioned, it can be confused with meta-learning. I think meta-learning is a general term to describe you have like a master model and you have a teacher model. And this master model produces results, and the teacher model is learning based on master model. Or also it can be understood as if you have, let's say, very computationally expensive tool to generate result, and you go step by step. You train your model one iteration on the very computationally expensive labeled data. Then you have new model, you produce new results. Then you run second iteration when you use a second model to generate new results, and this model is self-improving. And I think it's not the same with self-supervised learning. It's different concepts.
Amazing, great.
All right.
Amazing, good job.
Good job. Thank you.
Thank you so much, Aleksey. We're going to save some more questions to the very end, so we can have, but yes, please save your questions. It's going to be plenty of time at the very end for the breakout session. It's going to be a lot of fun. We're going to bring up to the stage Alex. Thank you. Yes, Alex has been here since the very first GPTuesdays in June of last year. So I just wanted to give a big shout out to Alex, my good friend. It's not been that long. And yeah, we're excited to. There we go. It's up. We're excited to bring you to also the GenAI collective community.
I'll just save it for there. I don't want to put it on. Okay. 1 second. You see, cool. Do I have to allow this? I think.
Yes.
Okay, there we go. I'll just share my entire screen. Or hold on, I'll do one tab. This one. Sure. Okay. Let's do this. Do this. Okay, sweet. I gotta do both of these. Okay. All right, test. You can hear me.
Round of applause for Alex.
Thank you. All right, I wanted to start with like one quick little like icebreaker, just to kind of get a feel for who the audience is. Raise your hand if this is your first GP Tuesday. Wow. Okay, I call that like half the people. Awesome. And because this is like an AI event, there's like a favorite question I like to ask. Who's used ChatGPT before? Okay, pretty much everybody. That's what I expect. But something I'm curious about is like the frequency of how much people are using these like LLM systems. So raise your hand if you use it like at least once a week. Some LLM system. Okay, once a week. I'd say it's like 30% of people. Okay, how about once a day? I feel like I got more people this time. That's a little over half. How about like every hour? And then who's using ChatGPT right now as I speak? Okay, we still even got a few people. Okay, and like one last question, just for the people who are like looking for jobs in the AI space. Anybody hiring? No bad. Okay, we got a few people hiring. So if anybody's looking for jobs in the AI space, you know where to go. Okay, that'll be it. I'll go on with the presentation. So I'm Alex. I'm going to be talking about measuring and benchmarking LLMs. A little bit about me. My day job, I work as, yeah?
Looks like it's not quite sharing quite yet.
Oh, whoops. Let me present real quick. Whoopsie. Entire screen. I thought I did it. Maybe success? Hold on. Don't mind me while I...
Yeah, just turn that on.
I see. I do not use this Mac that often.
Classic Mac.
Yeah, I'm not familiar. You do it? I appreciate it.
Text.
How many AI engineers have it take?
Yeah, how many entries does it take? Ah, okay.
Just gonna quickly.
Okay. Allow? Oh, thank you. Success now? Okay, cool. Awesome. So yeah, I'm going to talk about measuring and benchmarking LLMs. So
You said it can work in some words and stuff.
yes. For my day job, I work as an ML engineer, a company called Near. Doing a lot of ML engineering work. I can get more specific later. I like to classify myself a little bit as like a wannabe researcher and solopreneur. I do a lot of like blog posts trying to solve niche little math problems, and I run a few micro SaaSes on the side. Some like technical subjects that I really love are infrastructure, machine learning, and cryptography. talk to me about elliptic curves and isogenies. I will be your best friend. So I really love math, and kind of like outside of tech, I love like juggling and fidget toys. If you see me walking around, I'll probably have like a fidget toy in my hand. So the outline for this talk, and I'm going to go a little fast because I know we're eating up on time. The main outline I want to talk about for this presentation is what are benchmarks and why do we use them, especially with this whole generative AI boom. A lot of companies advertise benchmarks. I'm going to talk a little bit about these specific ones. I'm going to give it like a whole survey of these LLM benchmarking techniques. And towards the end, I'm going to be talking about if you have your own AI agent, AI assistant, or AI system product, some guidelines for how to build your own benchmark and some things to consider. And some of the goals of this presentation, some of the pieces of knowledge that I want to imbue onto you is one, how the foundational model creators, like the Googles, the Metas, Anthropics, the people who are making these foundational LLMs, how they advertise and compare their models with each other. Next, I also want to talk about the purposes of some of these different benchmarks. When you see some acronym like MMLU, which I will get into, what MMLU is trying to test. And the last thing is I want to get you all interested in measuring model results. So if you have your own prompts that you want to measure the efficacy of, I want to get you interested in like getting into the practice of measuring them. Okay, so I want to start like big and say just what is truth? Now, this is not a philosophy talk. I'm not gonna like spout a bunch of philosophy for the next like 30 minutes at you. This is to genuinely like motivate a point. I bought an epistemology book a couple of years ago, and according to this book, there's 4 big categories of truth. First one being correspondence, the relationship between observation and thought. This is very much like the scientific method. We have some observation, we collect some data, make some hypothesis, and try and like confirm the hypothesis with data. There's also coherence. Things that are true relate to other things that are true. Very much like an axiomatic math way of thinking. We have some sort of base underlying principles, and we try and extrapolate truth from these base principles. Another is consensus. Things are true because people say so. This is very much like, you can think like Roman Catholic Church and heliocentrism. Galileo was not a fan. You can also even think of just like the legal code that we all exist in. And like another last category of truth that I'll talk about is a pragmatism and being pragmatic. Truth is whatever works and is useful. And there are other categories in this book, but these are like kind of the main things I want to talk about. And the main point I wanted to kind of get across is that truth is extremely messy. All of us like use all 4 of these and more different mishmashes of different definitions of truth to try and ground us. And my sort of hot take is humans need truth to make decisions. We all rely on the sun rising every day to help us make decisions about how we're going to spend our morning, and many other truths that we all take like for granted implicitly. And AI systems are starting to more and more rule our world and rule our lives and are sort of the ground truth. For a lot of us, we have a whole like now generation of kids growing up with this magical brain in a box that they can talk to, that they believe is knows everything and knows how to reason about everything. There's like this concept in transhumanism called the exocortex. The idea of like we're sort of exporting a lot of our thinking and a lot of our knowledge to some other machine entity. And I feel a lot comfortable if these systems, I'm sure a lot of you would feel the same way, that these systems are telling us the right things. Because if AI is giving us like truthy outputs, then we're going to start to make very garbage decisions. We should try grounding ourselves in reality somehow. So kind of like the next immediate follow-up question is, how do we actually measure the knowledge of the truth, *TM, in our AI systems? And the standard that the industry has pretty much come to is benchmarks, the absolute necessary evil. So I'm gonna actually I'm gonna go to the next one. Yeah, so specifically I'm gonna be talking about LLMs. because that is pretty much the proto-AGI that all of us use like day to day. So all the big, this is just a mishmash of Meta, Google, OpenAI, and Anthropic, their self-reported benchmarks. And we're sort of given this barrage of different benchmarks, and some are saying, oh, look, we got this score on MMLU, and we got this score on HelloSwag. How are we supposed to like interpret that? If we get like, if one model is like 5% better on HelloSwag than another, does that really like matter? Should I care? Short answer is it doesn't really matter. I'll be honest. But we'll get into that. The thing is, we're given this huge barrage, and who knows? There's going to be new models that are going to be coming out probably tomorrow or next week that are going to report some numbers on these benchmarks. I kind of want to talk about specifically about some of the things that people don't talk about with respect to LLM benchmarks. One is that there's an absolute ton of them. There's no way that we're going to all know like every single LLM benchmark, but there's a lot of repeats that show up in these benchmarks from these big creators, so we're going to talk about those. And some of the interesting things are the devil is in the implementation details. No, I highly doubt, unless all of the big foundational model creators are talking with each other, they're all not implementing apples to apples comparisons, same prompt, same temperature, same other like inference parameters with respect to these benchmarks. They're all doing them slightly different. So it's very hard to get like an apples to apples comparison. Another one is all of them are reductive. An example is like standardized tests is like kind of an analogy I like to think about. Like, does IQ really measure intelligence? Does the SAT really measure literacy? Maybe they definitely test something. And kind of the big two last points is that some of these are useful, but most of them are just a marketing stunt to get you to use their model. Gemini reports, or sorry, some other foundational model like reports like, oh wow, we got like a 95% accuracy on MMLU. This is essentially used as marketing material to get you to use their model. Just want to state that. So, but we're going to talk about them anyway, just so you can understand what how you're getting like marketed to, just so you understand a little bit about what these companies are self-reporting. So I'm going to go through like the top 3, top 4 benchmark. There's a lot of them, so I don't have enough time to go through all of them, but go through the big ones. So the first category that a lot of them report is general knowledge, and the big one, the big daddy is MMLU. Stands for Massive Multitask Language Understanding. It's a couple years old, I think from 2021. It's from UC Berkeley, and it's basically a large multiple choice exam. It's 14,000 questions in the test split, and it covers like a wide variety of topics. Some of them, like it's claimed general knowledge, but some of these questions are pretty difficult. Sometimes they're like pretty specialized knowledge, like from abstract algebra, medicine, geography, a lot of stuff in there. And I kind of thought it was like this would be a fun exercise. I'm going to take a sample. This is a sample from MMLU in the nutrition category. The question, this one question is, which one of these organs has the lowest energy expenditure per unit of body mass? Take a minute to think. I'm kind of curious. I'm gonna see if I can like do a knowledge wisdom of the crowd. See if we all can get a point here. Okay, raise your hand if you think it's A, the brain. Okay, we got a few. Again, the lowest expenditure. All right, raise your hand if you think it's B, kidney. Okay, got another few hands. How about the liver? Ooh, way more hands. And lastly, skeletal muscle. Who thinks? Okay, I think that's like the most hands, and you are actually right. Wisdom of the crowd for the day. We got this one question of MMLU. Only like 13,999 to go. But the point is, I just want to give you a feel for like what MMLU is. It's basically this times 14,000. And how you actually benchmark against this model, you develop your system of prompts, chain of thought, or whatever, and you just have the LLM output like A, B, C, or D, compare against it, repeat against the whole data set, and you get a percentage correct. No curve on this test. Okay, the main things I want to talk about though are like the problems with a lot of these metrics, just so people can contextualize these benchmarks a little bit better. One thing is like, there's a lot of errors in these answers. I should have included an example in some of these slides, but this has caused like a bunch of different MMLU variations to come off, like MMLU fixed, MMLU plus, and a bunch of other varieties. Some of these problems are miscategorized. So like an example, that problem of nutrition, like does that belong in like maybe physiology or medicine instead of nutrition? So it's a little bit ambiguous. If a model gets like 90% on nutrition, does it know nutrition or does it know actually a lot about like physiology? There's definitely some ambiguity there. And again, like a big problem I think is like the clarity of the question and the answer can sometimes be pretty confusing. Anyway, I'm gonna keep going. One also interesting problem, this is with most of these benchmarks, is intentionally or unintentionally, a lot of these benchmarks have been leaked into the training data. So a result that like I reproduced is if you take MMLU in its original form and run it through a model, I was able to reproduce Meta's accuracy metric. Here, I actually got a little bit better. Score 1 for me in prompting, a few percentage marks better. But something interesting that you can see, and this paper goes into way more detail about perturbations of benchmarks. If you just simply randomly shuffle the questions, you'll actually suddenly get like 5% worse. You would think that like to us, like it shouldn't make a difference. If you like testing the knowledge of an LLM, it's like isomorphic, like a benchmark and a shuffled benchmark should be equivalent, but not for the LLM. So this is like a bit of a problem. Are we actually testing general knowledge, or are we actually testing like selection effectively? Another one is specialized knowledge. This is another huge category, and the big one that a lot of these companies report is GPQA. Stands for Google Proof Questions and Answers from NYU, combination with Cohere and Anthropic, and it's designed to test like the limit of human knowledge. You can think of it as like MMLU, like on steroids, kind of like a frontier knowledge. And it was written by people in the top of their fields, primarily in the STEM field. All these researchers went to people in the top of their field and said, "Can you make a question for this benchmark?" Interestingly enough, like I think it's special, like humans who are getting their PhDs score like in the mid 60s, while like us lowly humans who are not pursuing PhDs and we're given like infinite time with Google. I think it's like 30 minutes or an hour with Google. We only get like 30% on this benchmark. Yeah, and the big problem I think with GPQA, it's not so bad, but it's labeled usually as a reasoning benchmark, which I think is like a misclassification. It should really be just called highly specific domain expertise. Next is like programming. How long until the AI like subsumes all developer jobs? The two main benchmarks that are here that all the big companies report, they either choose MBPP, mostly basic Python problems, or human eval. And basically, this is just a huge 1,000 question Python programming test. And it's meant for like entry-level programming problems. And the way they're tested is you have a model generate some code. Inside of this data set, there are a few assertions, a few tests, and you just check, does the function satisfy the tests? But the main problems with MBPP and human eval is a lot of the problems are actually under-tested. There's not enough like tests to fully satisfy all the different conditions for the code, and also it's limited scope. A lot of people think that like, oh, if you score really high on MBPP, like the AI knows how to code well. That's not necessarily entirely true. MBPP is like focused more on like freshman level computer science intro to Python programming. So that's MBPP and human eval. So that's more of what it's testing. It's not general purpose programming. It's very limited scope. Another is math. How long till we prove the Riemann hypothesis? The two main, one or two of the main benchmarks here are GSM-8K by OpenAI, and its translated variation MGSM. And this is basically a huge bunch of word-based math problems. And I actually really like this one. I think this one's pretty good. There's only one little problem I have with this one. It's like super tiny, and it kind of applies to all of them. Is there's a little bit of final answer bias, meaning that, and this applies to all of them. We only reward like yes or no if you get the answer. We don't reward the actual progression of thought that you went through it, that you went through. Like, so what? The model was able to just intuit with a single token like 7. Like, we don't get actually the line of reasoning there. That's a much harder thing to measure. I'll keep going. This one is my favorite one, ELO-based benchmarks. There's really only one that exists. If you know, you know. It is Marina. Marina is amazing, in my opinion. It's a vibes-based benchmark. What that means is Marina was made by a company called LLMs. I think it's LLMs, that's the name of the company. Where all this benchmark is, it's like chess in a way, so it's given the ELO benchmark. We can actually do an example. You're given 2 different generations of 2 anonymous models. You mark which generation was better, and whoever wins from the human's labeling point of view gets a slightly higher ELO score. All right, well, we're gonna do one actually real quick. I think we have time. I want to do one real quick. Okay, so we have Model A and Model B on the left. I'm gonna type in, tell me about GP Tuesday Miami. And hopefully it'll do. Might take a second or two. And we're gonna judge which is better, and we're gonna see after we click which one is better. Okay, here we go. Okay, a lot of output. We'll only read the first few sentences here. GP Tuesday Miami is a monthly gathering for IT professionals focused on Microsoft 365, Azure, and related technologies. Didn't know that. And then there's GP Tuesday is a special event that has taken over various cities around the world, including Miami. It's an event that brings together pit crews and car enthusiasts. Who knew? I didn't know that. Yeah, they're both pretty bad. I'm not gonna lie, but I think like A is closest. Let's just hit A. And we can see that was actually Gemini 1.5 Pro. Funny enough, and this Model B was, I don't even know what that was. That sharp game maker. Okay, let me go back to slides and try and wrap up. A bonus metric I wanted to mention quickly, because I know a few people doing like translation job and localization, is machine translation is a whole task. And there aren't like official benchmarks that are reported by like the big companies or reported by individual researchers related to machine translation. But it's kind of like a fun fact is the very like first paper that introduced transformers, attention is all you need. They actually used machine translation as like their core measurement to like how successful and how good transformers are. And the big metric that they used was like BLEU, but there's other metrics like Meteor and TER, like translation error rate. We can talk about that later. Cool. The last one I want to mention is some honorable mentions. Some other benchmarks that you can look up on your own time is there's multimodal benchmarks. So the big one is like VQA, visual question answering it stands for. All it really is just a bunch of pictures with like 7 people and they say how many people are there and a bunch of different variations of that. Another is abstract thinking, which is the ARC challenge. This is Francois Cholet's benchmark, extremely difficult. There's also standardized tests, AGI eval, and there's some more interesting ones related to AI agents called Agent Bench. A few like interesting areas of research I would like to see more that I think are worth talking about are synthetic benchmarks that are generated either programmatically or by other LLMs. Another interesting piece is about token cost. Something that I think isn't talked about much is using weaker or smaller models and leveraging more tokens to try and get high quality results that you would get with some of the larger models. I think that would be interesting to see like not only accuracy, but how many tokens were used in achieving that accuracy. And the last one is about continual benchmarks, because I already showed that MMLU has probably been leaked in a lot of the training data for a lot of these models. I think it would be interesting to have like continual benchmarks that are continuously updated with new data, just so models don't have them in the training data. And we can sort of continually get like a fresh test of these like foundational models. Yeah, so now I'll finish off with some guidelines for building your own benchmarks. So a lot of these pieces of advice are similar to what I would give if you were just assembling your own data set or making your own test set for your application. The one biggest thing is like size isn't the most important thing. Size isn't everything. I really don't believe it is. It's about like having diversity in your data set and in your benchmark. Are you testing unique and like appropriate like cases for your specific use case? Second is thinking like a hacker. It's let me think of how to say this. Like you might feel that like, oh, when you're adding an entry into your benchmark, that's like a little bit ambiguous. Like, oh, my prompt isn't really gonna understand this, or my agent isn't really gonna understand this phrase, and this is gonna be a little bit too ambiguous, but it relates to the problem. That's like absolutely you should like put that in your benchmark. Thinking like a hacker means like, what are the edge cases to like break your system? And I think it's like really important to like collect these and like understand the failure modes of your system. So you should really try and think like a hacker and include the niche edge cases in your benchmarks. Next was like growing your benchmark from user feedback. If the user sees something bad as a part of your AI system, you should 100% recycle that back into your benchmark and make sure it doesn't happen again. So you know you're always like progressing a little bit. And lastly, my favorite is just a vibe check. This is like my absolutely favorite one. You should have some holdout set of like inputs and generation outputs that you see that is not automated, something that you look at personally, something that's just like a human thing, just to get the vibes for your AI agent or your AI system. Does this look like appropriate based on your whole context of the problem? Because at the end of the day, it's really like you building whatever AI system or product to make sure that it's appropriate. And vibes, I think, are extremely like a legitimate way to check. Yeah, I think that's pretty much it. So happy benchmarking. I'm on the internet. Please have a slide. You can follow me in all these places or talk to me after. Thank you, everybody. Oh, yeah, questions. Maybe one question.
I'm gonna do firstly. This was a great vibe, right? I'm gonna do a vibe check. How many people like this talk?
Thank you.
So I think we have time for one question, and then that's the questions we can have speakers later on.
Let's do after.
Can we turn off the lights as much as possible?
Thank you for a great presentation. I have three questions. How to hack human level benchmark? Is there any way to identify which model generated the output? Like distribution or some net information or some classification
Or grant.
Another classification model that will recognize, okay, this is Gemini. And it will always identify this is Gemini generated text, and it will always click model A or model B.
I have no doubt that somebody has probably made an algorithm to detect, to classify a model based purely on textual output, knowing there's a model. But it's probably hidden in the metadata of the actual Gradio website itself, so you could cheese it yourself. I'm pretty sure LLMs probably has like a separate group of people that are labeling privately the latest models that are part of their big A/B test. Thank you, everybody.
Awesome. Again, a huge round of applause for. By the way, the video recording of all these talks are getting recorded and live stream right now. So you'll get a recording of all the talks plus all the pictures right away. You'll do a magic trick and you'll get it before you reach home. That's no problem. Awesome. We have our next speaker, Kai. Kai works on a very futuristic tech. So while we get Kai set up, Kai works on very futuristic future of AI, which is the agent and small agent. So we're going to learn from him automated prompt engineering. Over to you, Kai.
Hello, ladies and gentlemen. Hello.
Share the screen to StreamYard.
Oh yeah. Hello, hello. I don't think this is functional.
Is it operational?
Yeah. Can you go ahead and share to your Discord one more time?
Oh, yeah. Oh, say a microphone.
Okay, we're good. All right,
yeah.
let's do it.
Hello. Hey. Nice to see everyone here. This is a pretty packed night. I think how many people are we at? 200? 203? Wow. Wow. 120
people signed up and 126 showed up.
Would you look at that? Yeah, let's go. That's incredible. When I was in Miami a year ago, there were barely any AI events at all. So it's been really fun. And so today we're going to be talking about automating prompt engineering. So essentially, by automating prompt design, you can essentially 10x your agent's performance, because the vast majority of an agent's performance is situated in the prompt and the instructions that you provide your agents. So a little about me. I'm the founder of Swarms. We're the first ever multi-agent orchestration framework. We essentially allow you to connect multiple different agents from different providers, like OpenAI, LangChain, or any other agent framework. And essentially, you can orchestrate these agents to automate real-world business operations. I also lead a research lab called Agora with 8,400 members. And I've been an AI engineer for a long time now. And so this is my personal website. If you want to email me, book a call, or whatever. Yeah, so what exactly is prompting? I don't think too many people understand what exactly prompting is. Prompting is essentially the instructions that you provide to an LLM. So it could be extremely specific, or it could be you could provide extremely detailed step-by-step instructions that show your agent exactly what it needs to do, how it needs to do it, and why it should even do it. Why should an agent do it? And essentially, we're going to be showcasing how you can create better prompts through a series of automated methods. So these are the most used prompting methods. Zero shots. When you hear zero shots, I know there's a lot of these buzzwords. But when you hear shots, they're not talking about shots. They're talking about just do this. So zero shot task is doing one thing at a time. So you say, create the code for this, generate an email. That is what zero shot means. It basically means do one very specific thing. Few shot. So what few shot means is you're providing a few examples. So that is if I say generate the Python code for this, I would provide the agents with a series of examples for this Python code. So I would say generate a function to send an API request to Anthropic. I would provide a call to OpenAI as an example. And so multi-shots is many examples. And essentially, this would be useful in the advent of analyzing any financial documents, sending emails. Generally speaking, with most advanced LLMs, the more examples that you provide it for your specific task, the more reliable it's going to be for this task. And so another thing that essentially provides a lot of performance when interacting with LLMs is just very clearly defining what the LLM should be doing. I think way too many people are trying to have LLMs that do everything all at once and not specializing enough and just doing one thing really well. And if you can do that at a certain degree, your agent's performance will essentially exponentially go up. So multi-shot is very powerful. The next is chain of thought. A lot of people have been talking about chain of thought. It's very simple, but also very effective. In some cases, O1 preview is essentially chain of thought, and you'll see here exactly what that looks like. So this is OpenAI's latest model that just came out. So just what it's essentially going to be doing here is providing the, it's essentially going to be thinking to itself, kind of how we think. We think before we take an action, sometimes we act without even thinking. But as you see here, it says, I'm listing, I'm thinking, I'm gathering, I'm mapping, I'm exploring. It's essentially, it's called internal monologue. It's essentially like when you think inside of your own head, this is essentially what chain of thought is doing. It's like thinking inside of its own head. So here you can see like all of its different thoughts, and then it gives us our task. So first it thinks, it essentially like maps out the space of potential answers, because there are a lot of potential answers for a given question. Ideally, when you use an LLM, you should receive the simplest, most direct, and easiest to understand answer that you can from an LLM. And so that's why it's all this thinking is essentially happening, which you see here, and then here you can see the response. The actual task is now completed. It first thought, and then it completed the task. So here we see zero-shot prompting, one-shot prompting, few-shot prompting, instruction prompting, role prompting, meta prompting. There's various different forms of prompting, and I heartily recommend that you first understand the nature of the task that you're trying to complete. And then you essentially try to mix and match these different prompting mechanisms to help you in your journey. Because every task is different and every LLM is different. And you have to understand essentially the limitations between each method and how to mix and match them. So after chain of thought, we have reflexion. So reflexion is essentially like think step by step, same as chain of thought, but then also it remembers the history. And essentially it tries to map the history to its chain of thoughts. And then on the other side here, we have a tree of thoughts. And so a tree of thoughts is one of the more advanced thinking mechanisms for LLMs. Essentially what it does is it thinks, and then it rates that thought on a scale from 0.0 to 1.0, 1.0 being the best. So essentially if you were to use tree of thoughts, that's like a map it, like imagine you're hungry at your home, and you're like, okay, what should I do? Should I go to the grocery store? Should I make food? Should I go out with friends? Like you're gonna assign a probability to each of these different possible options, and then you're gonna essentially search through, I don't know, the most comfortable or cheapest option, or however you're evaluating that. But essentially, tree of thoughts is you think, you rate this thought, and then you just do many thoughts all at the same time. So internal monologue is essentially what O1 Preview was doing. It essentially contemplates, it thinks to itself before it solves the actual task. And so by doing this, O1 Preview essentially maps out the space of potential answers and essentially builds up the foundation to complete a task, no matter how hard it is. Because no matter exactly how smart your model is, if you don't first build a foundation, you cannot build a penthouse without having a foundation. And that's essentially what it's doing. Another really popular mechanism is called react. When you hear react in prompting, it essentially means observe, act, and plan, and some combination of that. So essentially, the LLM will observe some form of data, say, oh, so if you say, I want you to send an email to John, it will say, first, I observe the user wants me to send an email to John. Then it will make a plan. It says, what shall I do? I shall make an email. And then the final thing would be act. The act would be actually making the email. And so React is very useful for like, oh, it's my computer. Oh. What?
Okay, we're good.
Oh. I'm confused.
You might share screen one more time.
Oh, yeah.
Cool.
Stream police.
Is anyone learning more about prompting right now? Yeah.
Okay, so those are basically like the most used prompting mechanisms. Yeah, so essentially I want you to think as all of these as essentially like Lego blocks. You have to mix and match them to find the best possible prompt for your task. There's going to be a certain set of blocks or prompting mechanisms that are most relatable to what you're doing. So first, understand what problem you're trying to solve with the LLM. Finance, marketing, programming. Like first, understand that, and then you have to essentially pick and sort the most valuable prompting mechanisms for this task. But the problem is that reliable prompting is extremely difficult. In fact, it's so difficult that the number of good prompters in the world is probably less than 10,000. And there's hundreds of millions of users of ChatGPT. There are not that many good prompters right now because because prompting is actually really hard. So prompting at the bare minimum takes at least 1 hour to create a really good prompt. It also requires extensive years of experience in whatever your field is. So if like the other day I was trying to build prompts for dermatology. I don't know anything about dermatology, so that also you also have to take that into consideration. And then you also need to iterate that prompt. You need to make it better, and that requires many iterations of feedback. It also requires you to understand the nature of the LLM that you're using. It requires you to understand the knowledge of the data that the LLM was trained on. Like Anthropic was trained on a lot of business contracts, because if you try asking Anthropic to generate a contract, it'll do extremely well. And it was you could tell Anthropic was trained on more and longer data than ChatGPT, because if you say, I want you to create a 5,000 word blog, Anthropic will not be able to do that. I mean, ChatGPT will not be able to do that, and Anthropic would be able to do that. And it also requires understanding the limits of the LLM. So LLMs have various settings. Temperature is essentially a metric of how creative an LLM is. So understanding how to manipulate the temperature is extremely important. Then you also have the number of output tokens, and you have a series of other settings that you essentially have to understand so you can get the most desired output. And you also have to have like extreme experience to just understand how to prompt LLMs. Prompting can be taught, but I honestly think that it's something that you need to have experience in. You need to just have like, it's like going to the gym, you know, like you need to like go every day, I guess. Yeah. So, yeah, go to the gym. Yeah, so reliable prompting requires extensive experience with LLMs. And so this is only for one AI. This is only for one agent. When you use ChatGPT, that's only one. That's only one LLM that you're using. Now imagine having to create multiple prompts for multiple agents. The complexity literally just like goes to the roof. It's not even like, the amount of time and energy that you're gonna waste is unbelievable. I have spent, I was trying to build a financial swarm at one time, and I spent almost 15 hours in one day building prompts for like 15 different agents. And that's like, you just can't do that. It's not scalable. It's also time inefficient. It costs a lot of your energy. It could also be costing you a lot of money. So what's the solution? The only solution is automated prompt engineering done by agents. And that is the purpose of our discussion today. And so automated prompt engineering is easy, reliable, and fast. Essentially, with automated prompt engineering, you can build production-grade prompts in 5 to 10 seconds just by saying, I want a prompt for this, and having ChatGPT or another LLM that you desire to create this prompt. You don't need any experience in prompting, and prompts can be autonomously upgraded. And that's crucial because you don't just build a prompt once and that's it. You have to essentially iterate on that prompt, and you have to continuously upgrade it to make sure that it's up to date with whatever input data it's being used on. It also doesn't require knowledge on the LLM's training history, and prompts can be structured around model settings. So you can say, if I wanted an LLM to create a story like a Japanese like haiku or something, you tell the agent, it will essentially create the settings for those prompts so that you don't have to do that. So it essentially strips away, through automated prompt engineering, you can strip away all the complexity that is typically required to build good prompts. And I'm going to be showcasing some examples right now. So this is a diagram of a more technical implementation of automated prompt engineering. And so at the top here, you have a request. So you say, I want you to create a prompt for this. And that's the top. So this prompt will then go to an agent that will then generate this prompt. And then you could also, if you had some results, or if you evaluated it like Alex's presentation, you could actually autonomously upgrade the prompts based on how it did from the eval systems. So Alex, this was an amazing preliminary discussion because this fits right in. And so you can integrate evaluations, if you wish, to autonomously upgrade the prompts so that you don't have to manually update those prompts, which would take a lot of extensive experience in your domain, which we probably don't have. And so the final thing is that the agent will then generate the prompts. It'll provide the context, it'll define the primary task, it'll define the output format, which is extremely, extremely important. It'll also set constraints, because when we operate inside of human society, we have a deep understanding of our constraints. And so we have to understand the constraints, we have, and then any exceptions, and basically it's finished. And so I'll demonstrate that in a couple of minutes. But this is a very simple prompt that anybody can use for automated prompt engineering. You can say, build a reliable production grade and extensive system prompt for an X LLM agent that does Y, provide step-by-step instructions, and provide multiple many-shot examples. Also provide constraints and rules such as Z. X is the agent's role. I want you to analyze the stock market. Y is provide extremely detailed descriptions of what the agent will be doing. Be very, very specific. Do not be vague. And like I said, you have to keep essentially like honing down. Z is any strict rules for the prompt to have. So in anticipation for this lovely discussion tonight, I have gone ahead and created an agent that does all of this for you. So you don't even need to write that prompt. So it's called the prompt generator agent, and it's on the GPT marketplace. You can actually use it right now. Does anybody have an example of a prompt they would like to see? Write you a song? About what?
Going to gym.
About the gym? What? Okay. What type of song? Reggae. Reggae.
Yeah.
All right then.
A reggae song.
And how do you spell that? Reggae.
R-E-G-G-A-E.
R-E-G-G? I don't know. It'll figure it out. All right, so here we go. We have the prompts being made right there. Would you look at that? That is pure diamond. This is actually, no, this is worth more money than diamonds. Look at that. You're a skilled reggae songwriter, specialized in creating uplifting and rhythmic lyrics that reflect the authentic essence of reggae music. Your task is to write a song about the experience of going to the gym, capturing the positive vibes, motivation, and discipline involved. Now, if you wanted to like actually use this, you would go to suno.ai, which generates songs, and then you would simply just copy and paste this. So you just copy and paste this, and boom. Let's see how it does. Oh, I need to sign in. Boring. All right. We're almost there. We're almost there. We're almost there. We're about to get some reggaeton. Where is reggaeton from?
No, it's reggae. Reggaeton is different.
Oh.
Reggae's from the island, the Grand also.
Oh. All right. All right, let's go. Oh. Too many, 200 tokens. That's very interesting. All right, so it's going to say, it can only take in 200 tokens. So we're going to say 200 tokens. Summarize this prompt in 200 tokens. So there you go. Now we didn't have to waste, very long time building that prompt. So now it's going to essentially generate the music. And yeah, so this could also work with images. So you can generate images as well. Well, this will work for anything that takes in text input as AI. So we'll see how it does. Okay, we got a song. Oh, that's weird. There's, yeah.
Yeah, you decided. Yeah. Go to StreamYard.
Yeah.
Tab, right click.
Yeah, I did.
Oh, you did? You click right click? And
Oh.
yeah, mute that one. So you'll see mute site.
Oh, yeah. Okay, let's see.
Feel the beat, move our bodies on repeat. Treadmills whirring fast. Morning light, break free. Gym time for you and me.
Okay, that's really bad. Okay, yeah. So yeah, so that's for like music stuff. You'd also do financial stuff. So let's go back and make a prompt for generating balance sheets. So I use this many times a day personally, because I'm developing multiple agents at a time. And so you can go here and basically do something like, and so now it's going to make that. And so, yeah. In essence, LLMs are better at prompting LLMs than humans are. That is essentially the meaning of this discussion tonight. And LLMs are better at prompting than humans because they have seen and they know how to mix and match these words to achieve a extremely precise prompt for a given task. Like I never went to financial school to learn about 10K quarterly reports. So I wouldn't know how to do this. So having ChatGPT help you, or even Anthropic has a prompt builder as well. Can I use it? Let me see. You have to pay money to them. They're not nice people. Well, that's not it. I don't know what that is. Wait, yeah. So you have to pay. So that's yeah, nah. So yeah. So basically, this GPT is usable. If you scan that little QR code on the right there, you can use it. Just like zoom in so you can get that QR code. And then we're also going to be building like an API for developers to like create tens of thousands of prompts for tens of thousands of different agents. So if you're a developer and you want to build a lot of prompts, I suggest you scan the GitHub one, and then we have the GPT that you can use right now, openly available. And so yeah, honestly, automated prompt engineering is the future because now it's scalable, easy, cheap, and every other benefit. And yeah, so this is some other QR codes for swarms. we are hiring agent engineers to essentially build a future of multi-agent collaboration. So that's our website, GitHub, and Docs, and that's pretty much it.
I'm gonna make sure that we share that reggae song with everyone who has needs motivation. Yeah, we should be promoting GenAI. We should be supporting it, even if it's not that good right now. By the way, anybody has any questions? We can take one question, and after that, all the speakers will be able to. Can you shout? Yeah. Screen.
What's your best resource to find like very nice professional prompters that you can hire, or I guess get consulting from?
I mean, ChatGPT. That right there. You know, like I said, ChatGPT is probably going to be a better prompter than 95% of human beings. So that I would honestly just recommend you to ChatGPT. I will be posting the full extent and all the resources relating to my presentation tonight. So I think those resources can also assist you. But in complete honesty, ChatGPT might just be what you're looking for. There's no need to overcomplicate things. Thank you.
I think that was awesome. And you know, like one great thing about these events is that I hate doing lectures, videos, but I love learning from the community. I love learning in person. Okay, you want to make sure that we got everything and we get everything. So okay, so that's with our speaker sessions. We are going to have now open networking and mingling. Feel free to go and talk to the speakers. Feel free to chat and discuss. I'm here as well. I love nerding out and having any deep conversation about what we talked today or anything else in general. And then if you want to stay tuned for events like this, this is the GenAI Collective calendar, Luma calendar. So you're going to get that in the emails as well following up this event. And if you want to find like-minded people and want to hire prompt engineers and other ways to join the Slack community and then go to the Miami chapter to start a conversation, any help that you need, all the builders going to be there and you can discuss your projects, get any feedback that you want. It's a really tight-knitted community of 20,000 plus builders all around the globe. And then if you want some more fun, you can join the GPTuesdays Telegram channel, right? And we'll have Grant for that.
Yeah. Amazing, amazing, everyone. If you want to join our Telegram chat so you can stay up to date and with all of us, please join our Telegram chat right here. We're a bunch of engineers, developers, business professionals, everyone just looking to have fun and getting to know more people in the Miami area and soon globally. I want to ask a question. Who thinks that we should be doing more collaborations with awesome communities around Miami? Absolutely. It's super fun time. Really, really appreciate GPTuesdays and GenAI Collective's collaboration. So I want to thank all of our speakers tonight, Aleksey, Alex, and Kai. I think all of us learned a lot from you. Who here learned a lot from our speakers? That's everyone here. Amazing, amazing. So thank you all so much. Next week, I want to just share with you a little bit about what we're doing next week. We have Noelle Russell. We'll go ahead and show her. Oh, okay, sorry. Anyways, we have Noelle Russell next week. She is a Microsoft MVP. She's actually on the board with the AI side for Miami-Dade College. She is an incredible person. Met her last week. We shared a conversation on the stage at the Adrian Art Center, and it was a really wonderful time. So if anyone wants to learn more about responsible AI and ethics, please swing by next week at this place, same time. And without further ado, let's go ahead.
No, yes. We need our picture.
Oh,
so
yes.
There's such a huge group of us. We're going to try to get you guys over here and take it this way if you guys don't mind. The other thing is if you've taken any pictures, videos, and you're posting, don't forget to tag at GPTuesdays on Instagram or your LinkedIn, anything like that. And with everything else, I think that's it. We can all head over and take that photo.
Yeah, let's take a good group photo. We have amazing photographer Esteban with us, and he'll help us make this moment even more special. So let's all go on that side.
Oh.
And then you can ask any questions and if you know.
Amazing.
And thank you all.
Thank you, everybody. I'm going to go ahead and end the screen.